All right, so we're going to continue with sequences. And if you look on the back of your notes, the next part is called a recursive formula. And it says it can be used to represent an arithmetic or a geometric sequence. And recursion is the process of choosing a starting term and repeatedly applying the same process to each term to arrive at the following term. So it's just if I give you the formula for a recursive, it's showing you what the pattern is, and then that way you can figure out the terms. Now it says for letter A, write the first 5 terms of the sequence. A of 1 is 8, and then A of n is A of n minus 1 plus 6. And so this notation looks a little funny, at least it looked funny to me, and so I want to try to explain it. So grab the extra paper that you were given and just find one of the sides that says figure number and then the process and the term value. And what we're going to do is create a pattern and show the pattern and show how we're getting it and tie in the notation. So the first thing is I'm going to start out with a triangle. And my triangle has 3 sides. So A of 1 is 3. And so that's my term value. The first term is 3. Now, to get my second figure, I'm going to take my first figure. So there's my original triangle. So I'm going to take my first figure, which is 3. And then I'm going to add 2 more sides to it to create a pattern. So I'm going to add 2, which gives me 5. So now I'm taking my first term, which was A of 1, and I'm adding 2 to get my second term. And I think I'm going to flip-flop the way I write it. Okay. And then to get my third term, I take my second term. So let's redraw it actually. Okay. That's my second one, right? A of 2. Well, I'll just keep it. And then I'm going to add 2 more, plus 2. So now I have 5 plus 2, which equals 7. And 7 is A of 3. And then my last term, my fourth term here, is I take my third term. There's my third term. And I'm going to add 2 more. So I'll get 9 altogether. So here what I'm doing, I'm taking my third term, which we know is 7. I'm adding 2 to get 9. And so if I were to write these out, A of 1 is 3, A of 2 is 5, A of 3 is 7, and A of 4 is 9. So I have a lot of numbers going here, but this is all about replacing. So anytime I see A of 1, I should think to replace it with 3. And anytime I see A of 2, I should replace it with 5. So that's how we get 5 plus 2. And anytime I see A of 3, I replace it with 7. So that's how I get 7 plus 2. And I could keep going and going and going, but I don't really want to. What I want to do is say, what is the process for any number? Any number is A of n. For any number, I take the number before it. So if I look here at A of 4, A of 4 is really A of 3 plus 2, right? That's what we figured out right here. And A of 3 was really A of 2 plus 2. And A of 2 is really a of 1 plus 2. And then we have to start somewhere. So this is where we started. So every time I use n, so let's say 4 is n, then in my second one, it's n minus 1. I took my 4 minus 1 to get 3. So that's how I say a of n minus 1 plus 2 every single time I added 2. So I have to be given a starting point. So we said we started at 3, and every time we take the term before and we add 2. So this is the term that you're looking for. This is the term before it. And then this is our common difference. So all of this is just to show you what is happening and how we're getting these little terms, these little, the notation. So if I go back and I look at my notes, and letter A says, write the first 5 terms of the sequence. So I need term 1, term 2, term 3, term 4, and term 5. I need to write the first 5 terms. Well, they told me that the first term is 8, and then every term is being added by 6. So 8 plus 6 is 14. 14 plus 6 is 20. 20 plus 6 is 26. And 26 plus 6 is 32. So I can put commas in here, and my pattern could keep going. But that's my sequence. Those are the first 5 terms. So my sequence is 8, 14, 20, 26, 32. Okay, so those are my first 5 terms. All right, I want you to try this one. First 5 terms in the sequence. I'm starting with 7, and every time I am adding 2. So 7 plus 2 is 9, plus 2 is 11, plus 2 is 13, plus 2 is 15. Those are my first 5 terms. Okay, the next thing is that you kind of want to go backwards and write the recursive formula. So that means you need to know the first term and then the common difference. So my first term is negative 2. So if I write this out, a of 1 is negative 2. And then a of n is the term before, so that's why we say n minus 1. And then I need the common difference. Well, to get from negative 2 to negative 5, I minus 3. From negative 5 to negative 8, I minus 3. And from negative 8 to negative 11, I minus 3, which means I'm going to say minus 3. All right, I want you to be able to write the recursive formula, but this is how it's been tested on the STAR test. Okay, let's look at a geometric sequence. So if you turn this paper over, you have some other patterns here. Okay. So this first pattern, I can see that I'm multiplying by 3. So the process again is that a of 1 equals 1. This is where we start. And then to get a of 2, I take my first thing and I multiply by 3. So I'm going to put the notation in there. A of 2 is really 1. 1 is my A of 1 times 3. And then to get A of 3, I take my 3 times 3. That would give me 9. Well, where does this 3 come from? That's this one, or I called it A of 2. So A of 3 is A of 2 times 3. And then the last one, A of 4, equals 9 times 3. And so I really say A of 4 is 9 is my A of 3, right? A of 3 times 3. And so every time, this is my n value, and then this would have to be n minus 1. And it's geometric, so we're multiplying, but usually we don't say we multiply by a number after a variable, so I'm going to put it in a different order. So I have A of 1 equals 1, and A of n equals 3. Sorry, we need to put that in front. 3 times A of n minus 1. Okay, so the 3 is going to, it should be in front. All right, that was just to show you the notation again. So let's go back to our notes. Okay, and we're looking at part C here. Write the first 5 terms of the sequence. Well, I know the sequence is geometric because it's multiplying. So my first term is 4. And then if I need to, I could use a calculator. 4 times 7, that's what I'm multiplying by, is 7. 4 times 7 is 28. And then I multiply that term by 7. So 28 times 7 is 196. And then I multiply that by 7. And I get 1,372. And that's my fourth term, so I need to multiply that one also by 7. And I get 9,604. So those are my first 5 terms. All right, you try this one. Okay, what are the first 5 terms in this sequence? So it starts with 2. Right, this is my start. And I multiply by -2. So 2 times -2 is -4. -4 times -2 is +8. 8 times -2 is -16. And -16 times -2 is +32. All right, and then the last part is just, can you write the recursive formula if I give you the sequence? And remember, it's where we started, so we're going to start with 80. And then what's happening every time is it's being cut in half. So 80 in half is 40, 40 in half is 20, 20 in half is 10. So my pattern is that A of n is 1/2 times the one before it.